Hi everyone, I am Manuel Boldrer and I'm going to present you our work entitled A Novel Framework for Multi-Agent Navigation in Human Shared Environments. The problem that we are going to address is the multi-agent navigation in environments shared with static obstacles and human beings as well. Basically, we want to steer our robots toward well-known goal positions. However, in doing that, we want to satisfy multiple requirements: robustness and safety in navigation. We must avoid any kind of collision. Socially aware motion planning, which means that the robot has to stay clear enough from the human private space, it has to follow smooth trajectories, and it should anticipate the human motion intention as well. Multi-agent coordination, we require a distributed coordination strategy between the robots. Management of dynamic environments, which means that we want the robots quickly and properly react to unmapped obstacles, reaching the final assigned goal position. And finally, computation efficiency. Basically, each robot has to compute the control inputs with an acceptable updating frequency by relying on lean hardwares. In this slide, we have the proposed hierarchical solution. This scheme refers to the single ETH agent. Given the CAD map, the initial position PI0 of the robot and the final goal position EI, these information are passed to the global path planner, which computes the global path PG. The global path is used by the local path planner, which has a space of interest of 510 meters and an updating frequency of 1.25 Hz. The human motion prediction model passes to the local path planner its estimated future position for each human being located in the space of interest. Hence, by relying on the predictive module information, the localization module, and on the LiDAR data, the local path planner generates the PL path. Finally, the local path, PL, is passed to the Lloyd-based controller that generates the control inputs V and omega. It has a space of interest of 3 meters and an updating frequency of 20 Hz. The synergy among these modules permits to not violate the 5 requirements listed before. The lack of a module results in a single or multiple requirement violation. In the extended abstract, we reported more details on the role of each module. Here we show an experimental result. We have 2 robots and a single human being, which is almost in a static position. The colored area around the robots represent the space of interest of the Lloyd-based controller, while the dashed line represents the path generated by the local path planner. The navigation results in safe trajectories followed by the robots, a good robot coordination, and finally the robots are able to achieve their goal position. In this case, we show another experiment with 3 robots and multiple human beings. In this case, the predictive model is fundamental in order to anticipate the intention of the human being and successfully avoid him. Also, in this case, the robots are able to safely achieve their final goal position in a socially aware manner. Thank you for the attention.